when Bill contacted me, I believe it was around 96, and he advised me that he had a group of colleagues, the Invisible College, and he said, have you still got the hair sample? I said, yeah, I do. And he said, would you want it to be DNA tested? And I jumped at the chance. I didn't even have to think about it twice. I was like, yep, let's do it. I trusted Bill too. I wouldn't have given that sample to anybody else.
No.
And I did have people ask me to give it to him to test, but that was the group that the guy had the T-shirt with some evidence and threw it in the bin.
Right. So not the group you want to give that to.
No, I'm not. And I'll tell you right now, if I did, that case would have been buried.
Yeah, you would have never seen it.
You would have never seen the hair again. You would have never seen the test. So I just trusted Bill, and I said, yeah, mate, come and pick it up, come and get it. And they took the hair, and the hair was gone for 10 years.
And this is the Invisible College.
That's right.
And this is Bill and his group of scientists
friends.
and like-minded.
That's right.
Sort of investigators and peers. And they take this sample and they do several DNA tests. You said it was 10 years?
I didn't have the hair for 10 years.
You didn't have the hair for 10 years, but you got the results, though.
We got the results, yeah. Bill had the hair for 10 years, a 10-year period. And
there were 2 tests done.
There were 2 tests done. And after the first test, they came to my house, a couple of scientists, the head scientist, Horace Drew, Dr. Horace Drew, and Bill came over and they took a hair sample of me. They took hair sample of my partner. Yeah. And they went away.
Yeah, to create a control.
Yeah. They thought it might have been, Vivian's hair.
But you also have to have a comparison as a control.
Yeah. So they had the hair for a couple of months. And then Bill contacted me and he said, mate, we've got some results here that aren't adding up. We want to do some more work on this. Will you give us permission? And I said, do what you got to do, And the second phase was the nuclear DNA testing. And in one of the tests, they found in the root of the hair, they had the rarest Basque, Gaelic, Scandinavian looking, tall, blonde, blue eyes DNA. And in the shaft of the hair, it had the rarest mitochondrial DNA.
The Chinese, Tibetan.
Chinese, the
Mongolian
Lahu, Mongolian, Lahu. And
that's individually 2 rare haplotypes. The Chinese Tibetan one being extremely rare. I mean, there's only a few other haplotypes that are more rare than that. One of them is like the Pygmy tribe.
That's right.
We're talking extremely, extremely rare. So already, first of all, it having 2 haplotypes in the same sample, we're talking
same hair,
is highly unusual.
Yeah.
There's some type of graft happening. This is before hair grafts. So there's some type of mix happening here. Now, at first, one might be quick to dismiss that as some type of contamination, but you have to understand that when testing these things are washed.
Oh, 100.
They are made sure that there is no contaminant whatsoever. So, although that's where people would interject, even that.
But the head scientist, they got to understand. He had written a number of books. He was, high authority on the DNA stuff, and if there was anything questionable, he would have discovered it.
Well, they were looking for it.
They were looking, They were trying to find something to discredit, not discredit, but to prove that something went wrong.
Because it's anomalous. It's an absolute anomaly. So, on top of that, the hair itself being the color and tone it was like a very light blonde or like a see-through, almost albino hair, and it was wispy.
Even more intriguing than albino.
Exactly,
albino, you see the white hair.
That's right.
Where this one, it was, when I said earlier, it was like wispy, but
see-through.
It was like see-through.
Yeah. They couldn't actually see it. They had to even when they were studying it, they had to use light to bounce off of it. That's because you couldn't see it. It was so faint and so transparent. Now, the idea that anyone with any type of Asian heritage having even blonde hair, is so close to 1 in a few billion.
It wasn't even blonde, it was white.
Yeah.
Like it was actually white hair.
And then what they did, they even tested your white hair.
That's right.
To make sure, they went through the ringer with this stuff to make sure that what they were looking at was indeed what the results were showing.
Yeah, they didn't leave a stone unturned, and they went about it the right way.
So on top of that, on top of having 2 sort of haplotypes in this mitochondrial DNA test, after that they do another test, which you mentioned.
Yes. What they found was a CCR5 gene deletion, and if you don't have that in your system, you're not
2.
That's right.
Yeah,
and you're not gonna catch sexually transmitted diseases.
That's right.
And when early on, when I had these researchers sit down with me and question me for hours and hours, and I said to them, like, these people are made for a reason. This is where it all comes together. And if you're going to have or make a being or a creature, male, female, whatever, and they don't have that, and they're not going to catch sexually transmitted diseases, it's part and parcel of what they're trying to achieve.
Of course.
You wouldn't have someone that's going to catch a disease and affect a child, a baby, or whatever, or affect them.
Another arrow pointing to this being engineered.
Yeah.
To this being being engineered in some way.
And the science, a couple of the people who did the research or the testing, even Dr. Horace Drew, he thought that the hairs were placed there on purpose, and wasn't an accident. And it's like these beings are saying, what's taken you so bloody long?
Oh, yeah.
And I can understand where people are now saying, same thing happened to me with the same beings.
Like a type of donation.
And I had a hair. I've also got hairs, but I've lost them or I dropped them or,
Okay. So before we get to there, I want to explain what the CCR5 sort of gene deletion means. Now, this is not, it's a chemokine receptor type 5. That's what it stands for. And it's a protein on the surface of the white blood cell. And what it essentially does, it acts as a gateway. So that protein goes around the white blood cell and then acts as a gateway for viruses. So if you're missing one of these gene receptors, you're pretty immune.
Yeah.
You have a good immunity to especially AIDS, but to sexually transmitted diseases. But if you have both, like 2 copies, which means you would have to have one from each parent.
Right.
Which makes it incredibly rare that both of the parents have this gene deletion.
Yeah.
They would make you almost completely immune to all that stuff, which is in Eurasian, so European Asians, fewer than 1% have like a gene deletion there. And that DNA would be like maybe one, just having that Eurasian DNA would be 1 in 100,000, then plus the gene deletion. If we add the blonde phenotype, let's say it's blonde, which is 2% globally. If we combine that, all of these different factors, we have the, this fact that it's a white hair, a blonde hair, from an Asian descent, from this small haplotype. If we add in the fact that it has these CCR5 deletion, the chances, and I ran this through like ChatGPT to see what the chances were, and it's 0. It's 0 in the population. It's 1 in billions.
Really? That's interesting.
Billions. Okay. So this is where it gets really, really interesting, because the tests that they were doing back then, now they have something called a high throughput sequencing.
Right.
With genes. So back then, they would look at base pairs, and they could only look at like one base pair at a time, and they could do a few hundred base pair using the PCR method to like duplicate the DNA.
And that's another thing with the
and we'll get to that. With the gentleman who discovered
Khoury,
exactly, who's had some experiences himself.
Yep.
But this PCR test, essentially, it revolutionized gene testing and DNA testing, because what this did was you were able to replicate DNA.
That's right.
And so you were able to do a bunch of tests with a very, very small sample.
That's right.
And it's what they use in crime scenes now. It's what they use in all these different things.
Yeah.
We might be familiar with it with COVID. We had PCR tests.
Yes.
And that's what it was. It was a small sample that they were able to extrapolate, a lot of information from, a lot of data.
Yeah.
Well, what you would do is you would do this, you would look at base pairs. You would basically sequence this and hundreds of times back in the 90s.
Yeah.
And that would take you weeks. Now, with the technology we have, you could do billions in an hour. It's insane what we can do with DNA nowadays compared to even 20 years ago, 30 years ago.
1992, 33 years ago. And
so my question is, would you be willing to have it retested with, and I'll pay for it?
Yeah, unfortunately, the hair was destroyed to a point where there's no root anymore.
There's not enough?
There's the shaft that I have.
Yeah.
It's minute, but my recollection is that Dr. Horace Drew said to me, this is over a phone conversation, not one-on-one in person. He said to me, look, DNA is we're in the toddler stage back then. He said, this is just starting. It's going to get much, much more advanced. And he said he's got a little vial with a little bit of DNA and it's sitting in his safe.
And he's saving it.
And he said to me, who knows what could happen in 10, 20 years with the advancement of, when they first did the test, they did it in a lab, a private lab.
Yeah.
I know in a couple of podcasts, they say CSIRO did it. No, it was CSIRO staff that worked there, but didn't do it through CSIRO.
Right.
They kept that separate. And I got the impression that, well, that's what I was told, that there was minute tube of DNA and 10, 20 years down the track, they could do a lot more with it.
I think that's today. I think it's
today. And I've asked Bill to ask Dr. Horace Drew to please go and look in his safe.
Yes.
Because I didn't make that up. That didn't just come into my head.
No,
I thought, he's got, I was told that he did. So maybe because he's done so many different things and he's just forgotten about it.
Maybe.
But I'm reminding him and Bill and saying, just check. You might find a little tube there, a little vial.
Yeah.
And it might have, and then maybe we can work with that. Now, I got contacted by a scientist from Western Sydney University, and he said to me, we need 1/6 of the hair, the size of the hair, and we'll tell you what they ate or what they eat. And I said, look, I don't have much of the hair left. I'm not going to destroy the hair, completely lose it and not have anything to find out what they eat. Like, I don't care whether they eat strawberry or whether they eat apples, I really don't care. It'd be good if we had enough samples. I wish they left a clunk of hair.
I mean, what's interesting here, that if you do end up getting it tested, and here's what matters the most, is because these tests and this study was not peer reviewed. No. And I know that's innocuous to compare that to what happened to you, because it's objectively something that's real. To say that, like, oh, you need this to be peer reviewed to be real is absurd. However, that would revolutionize science. Yeah. Because we're looking at something that, although after, doing the modern sort of throughput tests with it, the high throughput sequencing, we wouldn't be able to prove it's extraterrestrial.
That's right.
You'd never be like, oh, that's alien.
Yeah.
But we could effectively say there is nothing else, not only in the human gene pool, but even in the bacterial gene pool that matches this DNA.
That's right. Yeah.
And that type of anomaly would be groundbreaking.